In this video, we're going to take a look at the Model Mania Design Challenge from 2011. If you're unfamiliar with Model Mania, it's a design challenge held every year at SOLIDWORKS World where attendees are given a drawing like this, and they're tasked with creating the part inside of SOLIDWORKS both as quickly and as accurately as possible. Now, if that wasn't enough, when they're finished with the part, they're given an additional drawing with a series of changes and additional tasks to perform. So we're going to go ahead and dive right in creating this part. There's nothing really exceptional about this part. I should point out there are several ways you could create this. The order in which you could create the features, all these things will have an impact on how you make the changes. But I'm going to go ahead and start by drawing on the top plane, and I'm going to create that top profile first. Now, because the two circles are equally spaced from the center of the part, this is a great use case for the midpoint line. Midpoint line was introduced in SOLIDWORKS 2015, and it's a great way to quickly capture the distance from, say, the center of the origin. And you'll notice here that the endpoints always stay that same distance. So this way, when I go ahead and I add these circles out to the end of this, and they are two 40mm diameter circles, I'm going to dimension the first one. And notice on the second one, I'm going to leave this alone, and then I'm just going to make it equal to this one. Then when I go ahead and add this 60mm dimension between the two of them, the sketch is fully defined at this point. I'm also going to go ahead and add this arc that's going to be tangent to both of these circles. So I'm going to do this using a 3-point arc, and then I'm going to go back and add a tangency relationship after the fact. Now, because we conveniently have a center line here, I can go ahead and just mirror that arc over to the other side. And like the circles, when an entity is mirrored, it always maintains the same geometry on the other side. So when I add this dimension here, notice it adds it to the other side as well. I'm going to go ahead and trim this up at this point. I'm just going to remove these entities here, and I'm going to go ahead and extrude this to 30mm up. So the next thing we're going to go ahead and do here is there are some fillets that go on the top of this. So I'm going to go ahead and I'm going to choose my fillet command here, and it's a 6mm fillet on the outside. Now, an important thing to keep in mind is that fillet is going to be offset the wall thickness of the shell that we're going to create in a minute. So let's go ahead and do that now. Let's enter the 3mm wall thickness for the shell, and notice when I do that how it automatically offsets that geometry. Now, the next thing I want to do is I do want to create a hole through this entire part right here. So I'm going to go ahead and do this by sketching on the top plane. And what I'm going to go ahead and do is I'm going to go ahead and make this concentric to the center of this fillet right here. And this is going to be 22mm here. And again, I'm going to just draw the circle, and then I'm going to select the other one and make them equal to one another. And then I'll just do a cut through all. And you'll want to make sure that the direction is appropriate in that case. There's also a boss that it comes out from the side, but notice that it doesn't intersect this. Now, there are a few different ways you could approach this. I'm going to show you two different ways you could do this. You could draw the circle here. It's a 26mm diameter, and it's tangent to the top here, and it's vertical to the origin in this case, and we have this. Now, you could extrude this to two 20mm directions. So if I select the second direction, let's go ahead and make that 20 as well. You'll notice that you end up with this material on the inside of this. Now, you'll notice I didn't do this before the shell, and that's because the wall thickness is different. That doesn't mean you can't use that, though. Let's take a look. When I shell this, notice that it will hollow that out, but what we can do in this case is we could do the math. The outside diameter is 26, the inside is 16, that's a difference of 10. Divided by 2, that's 5. So in the shell, there is an option to specify a different wall thickness. And in this case, we could select these two faces, and they will have a different wall thickness. And in fact, we could, in that shell feature itself, select the two end faces as well, and automatically create those holes with that to save us a few extra steps. So, kind of a unique way of looking at doing that. Yes, you could have created that as a boss and then as a cut. And one of the other ways you could have done it would have been to extrude it from the outside into the part as well. But there you have it. We kind of have our part. The last thing we need to do is specify the material. 1020 AISI is in my favorites list. Remember, when you set the material on a part, you're not only changing the physical appearance of the part, but you're also changing the physical properties of the part. So this will impact things such as the weight or the strength of the part when if you ever decide to do a simulation on this, which we happen to need to do in phase 2. Speaking of, let's go ahead and let's look at the phase 2 drawing. The phase 2 drawing shows two significant changes to the part. The first is we're going to add this arc across the top. The next is we're going to add these bosses. Now this can get tricky, so let's go ahead and let's start with the arc. The best place to do this is the arc really happens before these fillets were ever created here. So we're going to go ahead and we're going to change this in this case, and we're going to just go ahead and add a cut. Now this cut will have some bigger implications on this part than what we may anticipate. I'll show you what we mean in a minute. Let's go ahead and quickly add the dimensions to this. The other thing to notice when you add an arc like this is to make sure that it's centered on the part. You could go zoom out, find the center, and make this vertical to the origin, but keep in mind another quicker way sometimes is just to make these two endpoints horizontal to one another. Now I want to cut with this geometry, and it's not a closed sketch. Notice when you choose to cut with a single line, and I, for instance, choose through all in both directions, it actually almost creates a surface cut, and it just allows you to choose which side to remove. So I could choose everything to the bottom or everything to the top in this case. And when I do that, it removes this. But when I did that, I completely removed the top face and all the original edges of that face. So this is going to get a little bit tricky because most of our features are going to have failures that take place. For example, these fillets can't find that edge that I selected. When I choose to edit it, notice that there's a missing face. That's okay. We'll just select the new face here and reapply that fillet. When we go ahead and we create this extrusion, likewise the tangency is going to be missing here to that original edge. And we can see this when we select on this arc. That's okay. I'm just going to go ahead and remove this, and I'm going to reapply the tangent relationship there. Now when I scroll down, you'll see that the shell does update itself with no issues there, so that was okay. The cut that we created in the part, there is a warning here. One of the things that's happened with this cut is that we had made this centered to the original fillets. Well, we changed those fillets. So in this case, I'm going to go ahead and select this, and notice this red dot. I'm just going to drag this out to this arc on the outside, and we'll reattach this, or maybe not. Maybe I'll just click and drag this, and we'll just do this the easy way. I'm just going to reattach this in this case. And we'll have to do this to both of these arcs. And then that will update, and then finally those fillets. But remember, there is this other new feature, these bosses that go into the part. Now there's a few different ways of approaching this. The first one is you could always add this after the fact. I'm going to go ahead and just draw these on my top plane, and I'm going to draw the diameters here that we need to work with. These are going to be 28 millimeters in diameter, and I'm going to draw two of these. Also here. Same thing like we did before, we're going to go ahead and make those equal to one another. Now when I choose to extrude this, we don't want to remove this inside material, so I'll use convert entities to capture those edges and copy that geometry down. Now you may be looking at this going, well, they're in the wrong place. Well, actually when you choose to do an extrusion, you can choose an offset option, and in this case we're given a dimension value of 30 millimeters, and then all I have to do is reverse the direction and choose up to body to join this together. Let's flip that direction around again. And we get what we need minus the fillets that need to be added. There was another way I mentioned we could have approached this, and we actually could have changed the way we did this altogether. I'm going to go ahead and I'm going to delete that sketch as well. One of the things SOLIDWORKS allows you to do is create the features in a different order than the actual sketch entities themselves. So here's what I'm going to do. I'm going to roll back to this feature here, and we're going to create a sketch on the top of this part. And I'm going to go ahead and I'm going to draw the 28 millimeter diameter circle here and the 22 millimeter diameter circle here. We just want to do the same thing on the other side. remember, mirror might be another way you want to accomplish this. I'm going to go ahead and just do this by drawing the geometry and then adding the actual relationships between the two. So I've created my sketch, but notice I'm not going to do anything with it right now. I'm going to go ahead and just continue to allow the part to rebuild as normal, and right now is a pretty good spot to do this. I could do this after the fillet even, but I'm going to save that for later, and I'll show you why in a minute. What we can do here is we can take a sketch that exists earlier in our tree, and we can go ahead and choose to extrude this and then choose an up to next in condition in this case. Now notice the hole doesn't go through the part. We can again reuse this sketch later if we want, and we can choose to do a cut, and with selected contours we could select just the whole piece in the center and choose a through all end condition in this case. So that's another completely different way you can do that, and something we haven't shown before. And that's that you can create a sketch anytime you want and then act with it or use it later on in the feature manager tree. So I'm going to roll this back forward, and the reason I save the fillet for the end is the fillet that actually goes on the outside here is the same radius, so we'll just go ahead and apply that there as opposed to creating an additional fillet. So we've created our part. There's one additional step we need to do, and that's we have to perform a simulation on this. If we look at the drawing, it gives us all the information we need. We need to fix the two faces that are kind of in that center cylinder, and then we need to apply a load to the tops of those new bosses that we just added. So in SOLIDWORKS, we could do this with SOLIDWORKS Simulation or SOLIDWORKS Simulation Express. Express is great because it's inside of every version of SOLIDWORKS, and it kind of walks you through the process. For example, the first thing we need to do is add those fixed faces. We do this by adding a fixture and simply choosing those faces. Fixed basically means that this geometry isn't going to move. This is where we're going to hold the part down. We could choose to add more fixtures, but we're going to go ahead and move on to adding a force in this case. And here we want to apply a force to these two faces on the top of this part. Now keep in mind when we do this, we'll want to be careful of the option here. We want to apply a 3,000 Newton load, but do we want to apply it to each item or overall? And in this case, we want to apply 3,000 newtons to each face. The next part of the step we've actually already completed when we specified the material earlier on. If we hadn't, we could define the material now by clicking the Change Material button. I'm going to go ahead and click Next and then choose to run the simulation. It takes SOLIDWORKS a few seconds to give us the results that we're looking for, and after it solves it, it gives us a preview of how those forces act on that part in an exaggerated fashion. Here you can see it's exaggerated by 219.7 times. This is just to confirm, is this what we anticipated? Yes, it is, so let's continue and look at the actual results. When we look at the results, one of the first things we see is the factor of safety. Here it's showing us that what we're seeing is a factor of safety below 1, but it also specifies the lowest factor of safety in the design is 2.76219. You could probably just round that to 2.76 to be safe. One of the nice things about this, however, is if, for example, we wanted to see a factor of safety below 4. This would help us understand where the weakest parts in our design are. Granted, plenty strong for the forces that we're applying to it. Likewise, we can also, if we wanted, calculate the deformation of the part by showing the displacement. And in this case, we can see the maximum and the minimum displacement on this part. So SOLIDWORKS Simulation gives us some great results, and there you have it, the completion of the Model Mania Design Challenge from 2011. If you're interested in learning more about Model Mania, or more specifically SOLIDWORKS World, it's rapidly approaching. I recommend visiting the link below this video or in the blog post where this is hosted.